This is Learning Assessment Problem 8.2. In this problem, we are going to compare various sinusoidal current expressions. We have three currents, I1, I2, and I3 of t, and they are written either in a sinusoidal function fashion or a cosine function fashion in order to determine the phase angles by which either I1 leads I2 or I1 leads I3. So to begin with the first comparison, we have I1 of t. At the moment it's written as a sinusoidal function, and we are to compare that with I2 of t, which is written as a cosine function. So let's convert the I1 of t to a matching cosinusoidal function so that we can do the phase angle comparison with I2 of t. So I1 of t will equal 2, converting to the cosine, we have 377t plus 45 degrees, and then we subtract 90 degrees to convert the sinusoidal function to cosine function, or I1 of t is equal to 2 cosine 377 radians per second t minus 45 degrees. So we want to compare I1 of t with I2 of t with respect to the phase angle. So we're interested in the phase angle of I1 minus the phase angle of the current I2 expression, and we see that this is so we see that difference in phase angles would be theta I1 minus theta I2, and this equals minus 45 degrees for the I1 of t phase angle, minus the 10 degrees associated with the I2 phase angle, and this is equal to minus 55 degrees. So therefore we can say that we can say that I1 of t lags therefore we can say that I1 of t lags I2 of t by 55 degrees, a minus 55 degrees representing a lag. Now we have the two currents I1 of t and I3 of t to compare with respect to their phase shifts. Both of these are in the sinusoidal format, and that's fine, but the I3 of t has a negative sign in front of it, and we want both these expressions to be positive. So we'll convert the I3 of t to having a positive amplitude, so we'll convert I3 of t to a positive expression by shifting the phase by 180 degrees. So this is 0.25 sine 377t plus 60 degrees minus 180 degrees for that negative sign in front, amperes. And I3 of t is then 0.25 sine 377t plus 60 degrees minus 120 degrees. then we can look at theta I1 versus theta I3 and say that theta I1 minus theta I3 for the phase difference between the two waveforms is equal to 45 degrees minus a negative 120 degrees, or theta I1 minus theta I3 is equal to 165 degrees for the phase difference. Should notice that in these three current waveform examples, all the frequencies were the same. The radiant frequency was 377 radians per second. This phase shift comparison would not be possible unless all the frequencies are identical.